So here's where we're going to start off with some review for Chapter 2. First of all, composite functions. If a function of x is given by x squared plus 2, then f of x plus h means we have to plug in the quantity of x plus h everywhere we find x squared. So in this particular case, we would have to expand this binomial by either FOIL method or the binomial theorem to get the following result. There are no like terms, so I'm just going to leave it like that for right now. Slope of a line. If I have 2 points, xy and x1, y1, then the differences in the y's over the differences in the x's, also known as rise over run, would be y1 minus y over x1 minus x, and this would give you the slope of the line. And point slope form. Often when you're given a function, they'll ask you to find the equation of a tangent line at that function. Well, you'd need a point by plugging the x value into the original function, and then you're going to need a slope, which would come by plugging the x value into the derivative function. Because again, derivatives mean tangent slopes, mean rate of change, means things like velocity and things like that. So point slope form, if I have a point at negative 2, 5 and a slope of a half, I take the variable y minus the y value equals slope times the variable x minus the x value. Now notice this is positive plus, it's positive 2 down here because I subtracted a negative is what was going on. So let's talk about what's happening in this picture. In this picture, a car starts off at some home base, and then eventually he gets about 300 feet from home and then just stays there. So what that would have meant is he'd have stopped again. So notice he goes from a 0 position and he goes to a 350 and he just stays there. But let's look at the changes in velocity. Number one, the yellow line. He starts off and the velocity is somewhat slow. It's not as steep a slope. The green velocity, he is now probably at the height of his velocity here. And then at some point in time here, he starts slowing back down and the slope gets less. Again, if I'm talking about position function, S of t here, then the slopes, the tangent slopes or secant slopes in that matter, represent velocity. And then at some point in time out here, maybe about 12 seconds, he got to 300 feet and he just stopped. Unless something else happens over here, it looks to me like he just stopped. So the velocity back again is a 0 slope line. Any horizontally sloped line, 0 means the rate of change or the tangent slope is 0. So let's do a secant problem. So I picked 2 points here. At 6 seconds, S of 6 was 250 feet. And at 12 seconds, S of 12 was 300 feet. And so we talked about the secant slope here. So all we did was the differences in the y's over the differences in the x's. We got 50 over 6, which is 8.3. So the velocity from this point, the average velocity from this point to this point is approximately 8.3 feet per second. And this would be a velocity. Again, remember that the y's measured in feet divided by the x's measured in second will give us a rate of change of some sort. Okay, that's good enough for today.